with a similar method that we just used with the special right triangle 45, 45, 90, we're going to do the same thing with the 30, 60, 90 special right triangle. This one, remember yesterday we reflected it twice in two different spots. Anytime that we're working with the top points here, we're working with the pi over 3. Anytime we have a denominator of 3, that gives me the 60 degree angle at the origin. And then if we flip it the other way, and I work with the pi over 6, it's the same triangle, but I have the 30 degree angle at the origin, and that's pi over 6. Again, we labeled them because I told you to yesterday, but here's where it comes from. If I have the 30, 60, 90 right triangle over here, again, on a unit circle, the radius, instead of being 2x, we can just call that 1. Okay? We do have distinct values here. The legs are not the same. The short leg is represented as x, the long leg is represented as radical 3 times x. So the math is a little bit more difficult because it's not just x and x. We're still going to use our x squared plus y squared equals 1. And they're both x's, but your x for x squared is your horizontal move. Okay? So it's just x squared. And then your vertical move is radical 3 times x. Alright, so I have radical 3 times x squared equals 1. Notice that this x is not underneath the radical. Okay, technically I could put parentheses around this x. I just took a shortcut. If you're multiplying an x in parentheses, it's still going to turn into x squared. When I distribute the square with the radical 3 times x, alright, we've been multiplying radicals a few times. It's radical 3 times radical 3, which is radical 9. Square root of 9 is 3. X, you're still multiplying that x by itself. X squared is x squared. Okay, so I have a very similar equation, just a tad different solving here. Combine like terms, 1x and 3x, make 4x squared. I divide by 4, so I get x squared equals 1/4. The taking of the square root is a much neater here because there's a square root of 1 and a square root of 4. Square root of 1 is 1, square root of 4 is 2. So x equals 1/2. Now, when I substitute this back in, the points are not the same. I put this back in. Well, x is 1/2. Okay, so if x is 1/2, the short leg is 1/2. Okay, so anytime I see a short leg, it's going to be 1/2. If I substitute the 1/2 in for this little expression here, I have radical 3 times 1/2. Well, multiply the numerator. Radical 3 times 1 is radical 3 over 2. Okay, so anytime I have the long leg, alright, let's label this one short leg, long leg. My long leg is radical 3 over 2. How do you remember this? Well, it's just a kind of trick. 3, even though it's radical 3, 3 is bigger than 1. Okay, so your long leg has radical 3 over 2 in it. Alright, so then if I label these, if I'm looking at this, my blue triangle underneath there, I have a short leg as an x value. That would be 1/2. The short leg is always 1/2. The long leg as a y value, that's radical 3 over 2. When I turn it for the pi over 6, I have a long leg as a x value as your horizontal move. So that means radical 3 over 2. And then my short leg is my vertical value. That will be 1/2. So anytime I have a pi over 3 as a radian value, anytime a 3 is in the denominator, not every time, but most times, it's going to be the point 1/2 radical 3 over 2. Anytime I have a 6 in the denominator, I'm going to have radical 3 over 2, 1/2. And those are interchangeable as you rotate around the unit circle, just like we did the other day. The final thing to talk about would be the points that are at 0, pi over 2, pi, and then 3 pi over 2. These are all on the x and y axis. So these are all points that have a radius of 1 because it's on the circle. So if I'm going straight out, it's a radius that's straight out. I go to the right, it's a horizontal move. That means my point will be 1, 0. I went right 1, I did not move up and down. If I go straight up to pi over 2, that's a vertical move. I did not move left and right, I went straight up. So I have the point, 0.01. If I go over here to pi, that means I just went left. Well, I go left 1 because that's the radius of -1. I did not move up and down. If I go down here, straight down to 3 pi over 2, I did not move left and right. I went straight down -1. So there's my building of the unit circle. I added your 0, pi over 2, and 3 pi over 2 onto there, but that's why it comes as well. You do not necessarily have to understand completely what I just did in these last two, in this video and the video previously. We're more concerned about the point, but this is the math behind this unit circle. Why does it actually work? Where does it come from? Some of us think this is very cool stuff and want to know the why. It's nice to know. It's not essential, but it is also part of how the math functions and relates from pre-calculus to geometry and algebra. Kind of neat stuff when you think about it.